Hello, good morning everybody. Thanks for coming. My name is Vicente Segura. I work in Telefónica Tech, specifically in cybersecurity, and I'm responsible for IoT and industrial cybersecurity. Today, I want to talk about this specific issue, this specific area. I want to explain what is happening, specifically in industrial cybersecurity, why is it happening, and also what can we do about it. So this will be the main topic of my presentation. First of all, let me start with a bit of context. You know perfectly we are in the middle of a digital transformation process, but this is something that started several decades ago. It has come in waves. First, we had an IT wave where internal systems were created in order to support actions that we made manually, like purchases and so on. This wave affects mainly to sectors such as banking, retail, more exposed to IT. Then the movement to the cloud and also going through the bring your own device trend, where many employees brought their own devices. And we are now in a new wave since some years ago, which is called Internet of Things, which is affecting especially the industrial sector. And it's affecting this sector because two reasons. First reason, it came with a set of legacy infrastructure that was created with the idea of being isolated, and now is being more and more exposed to the internet. And also, it's needed to create IoT services leveraged on different kinds of devices. Any device you can imagine where you add computation and connectivity, and it creates a complete new service. So if we look at what Gartner is saying, how this will evolve, right? We started with a completely isolated OT systems, OT meaning operation technology, industrial systems, where, as I was saying, we're completely isolated. But we are moving to the cyber-physical systems. What's that? Gartner defines that such as engineered systems that orchestrate sensing, control, networking, analytics capabilities in order to interact with the physical world. And that means that those systems can make things in real life. And this opens up new risks because these risks affect safety. At the end, the attack surface is expanded. And what we are seeing is a set of incidents each year affecting more and more the industrial sectors and the critical infrastructures. This is what you can see in this slide. It all started in 2010 with Stuxnet affecting some Iranian nuclear power stations. But after that, a lot of incidents has happened affecting these critical systems. Particularly, I would highlight those happening in 2021, affecting some water treatment plants in Florida, and also, although this wasn't an OT incident per se, affecting Colonial Pipeline, which is one of the main midstream companies in the United States. But this hasn't stopped here. Last year, 2022, the trend continued. And what I want to highlight in this particular slide, it's one particular incident or kind of malware, which is called incontroller. You can see it in the middle, in the right side of the slide. What's incontroller? I think this is a game changer. Probably you will remember Mirai. Mirai was a malware framework which was released in 2017, which affected IoT devices. It was able to scan IoT devices in the internet, find devices which have default password, take control of those devices, and launch DDoS attacks. In my opinion, incontroller is similar for the industrial world because it's like a framework, a software framework you can reuse in order to create a specific malware for new devices. And in fact, what you can see in the slide, is the Purdue model, typically in industrial architectures, industrial network architectures. On the top of the slide, you have the enterprise network. On the bottom, you have PLCs and key devices you have in factories. But this framework, this software framework called InController, is composed of different modules you can reuse to create your own malware. First one is TagRun. TagRun is able to find OPC servers. OPC is a protocol used in industrial environment in order to store information about the assets you may have in your plant. So in this InController component, what you can do is to find this OPC. It's kind of reconnaissance of this kind of servers. Then you have two other components called Code Call and OMShell, which has been specifically created to exploit vulnerabilities on specific assets. In the case of Code Call, it was found that it's able to exploit vulnerabilities in different Schneider PLCs. And in the case of OMShell, it is able to exploit vulnerabilities in OMShell server components, which are able to control engines. So with this kit, you can exploit vulnerabilities in a lot of industrial plants. In fact, it's interesting that now manufacturing is the sector that tops the most attacks sectors by cybersecurity incidents. This was not the case before 2020. Traditionally, the financial sector has been the most attacked. And this is obvious because attackers want to get some return on their attacks. So they were focusing on finance because that was where the money was at that moment. But this is changing, and this is changing because manufacturing is opening, or manufacturing plants are more connected, more open, and they have not designed with security in mind. So that's the reason they are in top of this ranking. In fact, if you compare with the same report released in 2018, the right-hand side report is from 2021, and the one in the left is 2018, you can see that manufacturing has moved from the 4th position to the 1st position, and also energy has moved from the 10th position to the 4th one. And why is this happening? I try to summarize that in this slide. What you can see here is, again, a network architecture more or less with the following the Purdue model. You have the corporate network in the top, plant network, and the control network on the bottom. Of course, you can say, you have firewalls there. Yeah, you have firewalls, but most of the time, those firewalls are not properly configured. They don't have the rules implemented that restrict the not necessary traffic. So, in addition, you have insecure remote access. Typically, it's needed to provide remote access to your plant because you have to give that access to operators from third companies, or just to provide remote access to solve any problem you may have. This is one of the key problems, the insecure remote access. In addition, misconfigured firewalls, as I was saying, that when you analyze them, they almost provide or give you access to everything. They are not properly filtering traffic. Also, infected laptops. There is no policy to scan a laptop before someone goes into the plants and connect the laptops to make some operation. Additionally, insecure wireless access. Also very common because the operation team needs to provide some remote access very quickly and then install some kind of router to provide remote access. Infected USB. This is still a key problem here. Not good policies, so anyone can take a pen drive, connect it to engineering station, and it may have viruses, or also it can be potentially tampered to generate an electric discharge and leave the engineering workstation in proper state. Also infected PLCs or insecure serial links. These are another problem. So what can we do about it? This is the second part of my speech. What I want to share with you is some practical use cases we have learned with several customers we have had the opportunity to work with. So first case for me is, what assets do I have in the plant, and also which risks are they exposed to? This is the key initial question, because CISOs typically are assuming the responsibility of the cybersecurity of industrial plants. And when they assume that responsibility, normally they come from IT world, and they do not know what's in the factory. So how are they supposed to protect something they don't know what contains? So the first stage would be, well, the first question would be, I need to solve this miss of information. And again, I'm showing here the network architecture following the Purdue model. The top layers, typically from the IT world, in most of the companies, are well organized. CISOs know what's there. This is control. But what you have below is not control. You do not know typically what is there. This is the key problem, because how can I protect something I don't know well? Even in most of the cases, they are not organized from a design point of view, as you see in this slide. There are no cell zones segmented between them. There is no proper segregation between the IT network and the industrial network, and so on. So what we do in these cases is to start to understand what's in these factories. We make what we call an industrial cybersecurity assessment. And we follow two activities in parallel. First activity is to collect theoretical knowledge based on meetings and based on documentation that is already available from the company. So you have an idea. This is the bottom line. In the top line, we make a technological assessment. And that means getting insights directly from capturing traffic and analyzing the traffic. And this is good to have these two activities in parallel, because you can compare both and see if what you have discovered in meetings matches with what you have found with tools that allow to analyze the traffic and provide you information and assets and so on. This is an additional slide providing a deep dive on how we do this technological assessment. Typically, you have to find some points in the network, potentially span ports. If you do not have span ports, maybe you have to deploy some element like TAP to make a passive copy of the traffic and collect that traffic. Once you have that traffic, you have several tools that can analyze it. Tools typically are IDS, OT IDS, I mean intrusion detection systems created for the OT world, that are able to analyze the OT protocols like Modbus, Profibus, Profinet, and so on. And then those tools, when we use several of them, provide information on what you have in the factory. For example, the assets, the type of assets, if they are PLCs, if they are engineering workstation. Also the communication relationships between the devices. In addition, potential malware activity, connection to the internet. These are information you can collect at this step. And with that information, you can have a clear view on how is your factory. This is an example of a report that we generate based on that information. On the right-hand side, you have a summary of what you can find. Number of OT systems, IT systems, potential misconfigurations you may have. Could be different devices using the same IP. You know that because they have different MAC addresses, for example. Connectivity problems, malware activity. At the end, different issues you should solve. And the most important part is the recommendations. Recommendations is how can we improve this? And if you want to deep dive on that, you should have a plan, a security master plan, prioritizing those recommendations. Those recommendations could be segregate your IT and OT networks, segment your OT networks, deploy monitoring solutions, deploy an USB protection solution, things like that. Then I want to move now to the second use case. Well, we already have what we have in the plans, and could be something like this. We have a network scheme of your plant that shows you how do you have arranged the different devices in your plant. And in this slide, we can see several problems. First of all, we don't know if the element that connects the production network with the office network is a firewall or not. If it's a firewall, we should assess if it's properly configured. In addition, you have engineering workstations which are connected. We don't know if the different cell zones, which are the different boxes you have around the production in the production network, are properly segmented. And in the top line, in the top side of the slide, those boxes in pink represent connections between the IT and the OT world. For example, servers used for interaction with industrial control systems, or clients used for interaction with industrial control systems. And this is the situation. The potential problem there, as I was saying, is we don't know if there is a good segregation IT-OT, if there is a good segmentation between networks, if there is a good mechanism to provide remote access, and so on. So what can we do to make a secure network design? This is shown in the next slide, this one. We have to rearrange some of the devices or assets that you have in your plant. First of all, starting from the bottom, as you can see there, we have segmented the OT networks. We have assembly, manufacturing, and packaging. These are different cell zones. And we have connected those networks to a firewall. That firewall ensures that there's no a potential lateral movement in case an attacker gets into one of those networks. Because this is easy to say, not so easy to implement, because you need to understand the kind of communications that are there and to define the kind of policy rules that you need on that firewall. But for sure, this improves your security. Also, you can see a component called IDMZ firewall. This is the IDMZ, it's Industrial Demilitarized Zone. And this is a network you create in order to control the communications between the IT network and the OT network. Instead of going directly, they go through the demilitarized zone network. Why? Because then you control how IT and OT networks are connected. So that means that you will deploy the remote access gateways in that network, and you would also deploy other servers that you need to connect to internet to get updates, like antivirus and patch management. And also you can see in the right-hand side an operations networks, which is a network specifically created for those engineers that need to have access to human-machine interfaces, SCADA servers, and so on. Well, let's move now to the third practical use case I wanted to share with you. Once you have solved, first thing was to understand what I have in my plant. Second, let's put some order in the network architecture. Third is, how do I improve my incident detection capabilities and provide asset visibility continuously? Because your plant is a live asset in the sense that it will have new assets, it will have some changes, even they are slight, but you need to have an updated view on that. And what I am showing here is the attack path of a specific incident which was called Triton. And as you can see, in this attack, first of all, the attackers were able to take control of a IT computer. Once they had that access, they were able to compromise an engineering workstation in the OT network. Well, how do they took control of one computer in the IT? Using different techniques. You can use phishing attacks. At the end, the easiest way is to get some malware installed in the computer of an employee. And in fact, we have applied this technique in some activities with customers that have asked to test them, their security capabilities. And once you get access to the computer of a relevant employee, you may collect important information. In some of the cases we have made with petrochemical companies, we were able to get passwords for access to some engineering workstations, like the one you see here. And when you get control of that engineering workstation, in this particular incident, which is Triton, the attackers were able to manipulate the protocol that was used to access the safety systems that control the PLC. Those safety systems are able to block or stop the process in case that there is something strange, like high temperature or high pressure, something like that. So they were able to take control of those systems and block them. So at the end, there were a physical incident, as you can see in the image. So the point here is, what can you do to detect this kind of incidents? And as an example, I'm bringing here a managed security monitoring service, an example of one service, right? And this is composed of two layers. The bottom layer is the technology layer. You can use different technologies here. In our case, we use Nozomi, but there are others. But the particularity of these technologies is that they are able to analyze the traffic and detect incidents specifically created for the OT environment, because they are able to analyze those protocols, because they are able also to collect information about the process variables and detect when there is an anomaly. But at the end, they are intrusion detection systems. They generate a lot of events. We added this managed service layer in order to filter those events and to create detection use cases so that the service is not too prone to generate false positives. And this is what we particularly added to this service. Beyond that alert management capability that I was mentioning, the managed service layer is able to detect potential problems with the elements, the technology elements that you deploy. At the end, you need to deploy some appliances that analyze a passive copy of the traffic. So if any one of these devices is off, they can detect it and start it again. And also generate reports that provide information about what the service is providing, which kind of assets have been detected, which kind of problems or risks remain in the infrastructure, which kind of incidents have been detected, and so on. This is a deep dive on the components of this service. In the customer's infrastructure, you have those appliances I mentioned, and this is connected to the SOC, to the Security Operations Center. And the box called Orchestration and Automation Platform has the intelligence to implement the detection use cases I mentioned before. I will get into that in the next slide. You also connect with what we call Threat Intelligence Platform. IOC is the acronym for Indicator of Compromise. This is like a database of indicators of potential incidents. It could be an attacker's IP. It could be a type of malware. And this database is shared among all the customers. And that allows us to understand if a particular IP has attacked another customer. So we can have some insight about that IP in advance. There is also a customer portal for accessing to those reports I was mentioning, ticket management, because at the end, in the case that some incident cannot be solved automatically, level 2 will act and will try to understand what is happening. And this is an example of incident management procedures, the detection cases that I mentioned that we created. Because, again, what we want is to avoid to have false positives. So we identified 20 cases of potential detection use cases, and we created specifically procedures. For example, internet browsing. What can we do if we detect a device which is trying to access the internet, and it shouldn't access the internet? Or this is more interesting, maybe, new node. Imagine that you detect a new node connected to your network, to the network of your plant. What we do? We try to identify which asset it is, with whom it's connecting, what kind of application it seems to be running, and with that information, we provide the report to the operations team of the customer and try to make something. If it's normal, it's an accepted device, that's okay, but if that node shouldn't be connected there, we can block it. And there are others, like engineering operations, if we detect that there is some change in the program running on the PLC and so on. Each one has its own particular procedure. And finally, once you have the detection system in place, what else you can do? You can try to be before or advanced to your customer. And what I'm showing here is kind of a honeypot, a replica of your systems exposed so that it receives attacks from potential attackers before your real systems, so that you know who is attacking, how are they attacking, and try to get information from that and be prepared. The right-hand side shows what you really have in your factory, which is the box with the man with the white hat. And the man with the black hat shows what the attacker thinks it is. So the attacker thinks that it has a real factory, but in reality, they are accessing a simulated or a replica of a real system. Finally, to conclude what I have shared with you, this slide shows how we propose to face cybersecurity needs in industry. First, start with assessing how are your plans and planning. What should I do in order to improve my security level? Then start implementing different solutions. And remember, solutions is not just technology. You need to make sure that people understand why do you deploy this kind of solutions, like remote access. And you also need to define processes. If you want to access remotely, you need to create a user, you need to use second factor, access in this way, and so on. And finally, there is no magic in the solutions and in the technology. Every solution needs to be managed somehow. And this is a summary of how we propose to start implementing this solution I mentioned. First of all, start knowing yourself. This means making these assessments and having a security plan in place. Second stage, defend. Start segregating IT and OT and segmenting OT networks. Then contain, segment those cell zones and also protect the engineering workstations. Then move to monitoring. And if you reach that level, then you can start doing things like generating your own threat intelligence using this kind of honeypots and so on. And that's all on my side. Thank you very much for your attention. And if you have any question, more than happy to try to answer. One question there, right?
Thank you. Oh, okay, it works. Hey, I've got a question. When you mentioned one of the first things to do is to apply network segmentation within the OT network. So how would you that do if you would have more of a DCS, so a distributed control system, in which all of the components kind of need to talk to each other? Can you still apply segmentation in that case?
Yeah, I think that's potentially possible. You need to understand each specific use case, particularly latency issues and so on. But this is possible. There are solutions to do that. So need to understand the specific use case, but I would say that that's possible.
Thank you very much for the presentation. My question is, what solution providers do you consider more advanced in order to secure the OT environment and the IoT devices?
You mean in general or specifically for some of the solutions that I've showed?
Yes, like the Palo Altos, Fortinet,
Okay.
Cybervision.
Yeah, that's a really good question. I would say that it depends on what you are looking for. For example, segregation, segmentation. You have several good vendors there, like you mentioned them, Fortinet, Palo Alto, even Cisco also, Checkpoint. These are the usual suspects for that. If you move to monitoring, you need to look for a specific solution. I know that Palo Alto has one, which is Syncbox. It comes from the health world, not specifically OT, but they are improving that. You also have there several providers, several vendors, such as Nozomi, Clarity, Dragos. There are some good ones. And regarding endpoint protection, the matter I found there is that if you have legacy operating systems, you have a problem there, because the good ones you have in the IT, like, you know, CrowdStrike, Palo Alto, Sentinel-1, whoever it is, you are not sure if they will support Windows XP, Windows 2000, and so on. And then you have others there, like Trade Micro, and so on. So there are a lot of them. So it depends on the case. I would say it depends on the case and the specific solutions you need. There are several players. Hope I answered your question. Okay. Any question? So thank you very much. Thank you very much.